So you'll also recall from our limit definitions of the derivative that one of our assignments there was to find the equation of a line tangent to a graph at a given point. And with that limit process, it was kind of exhausting. We had a lot of steps to do, and it took some time. But it turns out that if we know our tricks, now we can go through and use these rules in order to rewrite this and find the equations of lines that are tangent to a graph. First things first, if we want the equation of a line, we need two things, right? Recall that we need a slope and a point. Well, we've got a point, right? We know that our function passes the point -1, -2. So the question is, what is the slope? And once we find those things, what we're going to do is we're going to substitute into our point slope formula. You recall that was y minus the given y value, y1, equals the slope times x minus the given x value, this x1 in this case. And so our real job right here is to find that slope. And what that means is that our slope, as we defined it, the slope is equal to the derivative of f of x at the value -1 right here, right? So if we find that derivative, we're actually finding the slope of the line at any point x, and that derivative function is a slope producing formula, and so we use that slope producing formula at x equals -1, and we're going to find that slope. So here's the way it goes. Of course, we know what f prime of x will be right here by our power rule. F prime of x is equal to, let's see, our first term is x cubed, so we take 3 as a multiplier in front, and it becomes 3 times x to the 3 minus 1. Well, that's the second power, plus the derivative of x to the first, is just equal to 1. And so our derivative will give us our slope at -1 when we substitute in -1 for x. So to get our slope, let's take f prime of -1, that's 3 times -1 squared plus 1. We know that when we square -1, we get +1. That's 3 plus 1 now, and so our slope is equal to 4. Right? And so we're most of the way there. Now we need to substitute in our values from our given point along with our slope to develop the equation of this line. So we write y minus -2 using the given y value from our point times the slope of 4 times x minus the given x value. In this case, that's -1. We get y plus 2 is equal to the quantity 4 times x plus 1. And let's rewrite this in a form we know, the slope-intercept form. This becomes y plus 2 is equal to 4x plus 4. And if we subtract 2 from both sides to isolate y, the equation of the line tangent to the curve at -1, -2 will be the line 4x plus 2. That's exactly what we wanted. Hooray.